Hello, I welcome you all for this lecture 2 on the topic of hydraulic turbines. In the previous video, we have discussed regarding the introduction to the hydraulic machines, the hydraulic turbines. We have discussed about the different criteria based upon which we can classify the hydraulic turbines. We also had a discussion on the impulse turbine, that was nothing but an impulse turbine as such. The Pelton wheel is one of the important type of the impulse turbine. We have seen the construction features and the working principle for the Pelton wheel. And toward the end of the lecture, we have also seen regarding the various types of the efficiencies which are applicable for the impulse turbine. In this particular session, we will look at the various design aspects which are applicable for the Pelton wheel. Additionally, we will also focus on the mechanism that is used to govern the turbines. Alternatively, it is known as the governing of the turbines. Coming on to the design aspects of the Pelton wheel. So these are some of the parameters which are taken into consideration for the design of a Pelton wheel with respect to the given data to us. The absolute velocity of the jet V1, so that is mentioned as CV under root of 2gh, where CV is nothing but known as the coefficient of velocity, and its value ranges between 0.98 to 0.99. The H is nothing but the net head which is available at the inlet of the turbine. The velocity of the wheel, that is small u, so that is expressed as psi under root of 2gh, where psi is a constant known as the speed ratio. The speed ratio ranges between 0.43 to 0.48. While discussing the working principle of Pelton wheel, we have seen that the jet which is issued from the nozzle, and after making the impact at the splitter for the bucket of the Pelton wheel, the jet is deflected in either directions. So unless otherwise stated, this angle of deflection that is considered as 165 degrees. So if the value of angle of deflection is not given to you in the statement of the problem, so one can assume that the angle of deflection is 165 degrees. The jet ratio represented by symbol m, so which is nothing but the capital D divided by small d. Capital D is nothing but the diameter of the wheel, and small d is nothing but the diameter of the jet. And normally the value of the jet ratio, so that is taken as 12 in almost all the cases as far as the design of the Pelton wheel is concerned. To evaluate how many number of buckets should be placed around the periphery of the runner, so that is expressed as Z. So number of buckets Z equal to 15 plus D divided by 2D. And toward the end, in the one of the construction arrangement for the Pelton wheel, we have seen that it is not only a single jet that is popularly used for the Pelton wheel, but number of jets may also be mounted to get the increased output from, or to get the increased runner power from the turbine. So multiple number of jets is also the common feature for the operation of the Pelton wheel. So the number of jets can be calculated as the ratio of the total rate of flow through the turbine to the total rate of flow of water through a single jet. Okay, so these are nothing but some of the important design aspects as far as the Pelton wheel is taken into consideration. Coming on to the next point for the discussion, which is important to us. So that is nothing but the governing of the Pelton wheel. So in simple terms, I can say that the governing is nothing but a process by which the speed of the turbine that is kept constant at all the operating conditions. Okay, it is the mechanism which is used for governing of the Pelton wheel. So that can be seen in this block diagram. It is important for us to first understand what is the meaning of the governing. The governing of the turbine that can be defined as a operation by which the speed of the turbine that is kept constant, and it is essential that for all the working conditions it is necessary that the speed of the turbine should be kept constant. It is done automatically by means of a governor. The governor is the one which regulates the rate of flow through the turbine depending upon the load on the turbine, whether the load is increased or whether the load is to be decreased. So the load of the turbine, that not necessarily it remains the constant. It is subjected to the fluctuating as well as this, let us say, the variable load conditions. The governing of the turbine is the one, so that is necessary, as we know that the turbine is normally directly coupled to the electrical generator in actual conditions. Okay, so it is required to be run at the constant speed under all the fluctuating load conditions. This is one of the important, what you can say, the parameter as far as the consideration of the governing is taken into consideration. The frequency at which the power is generated by the generator, okay, with the constant number of pairs of the poles, okay, considering under all variable conditions, so that should be constant, isn't it? The frequency of the power generation, so that should be as such a constant under all the variable load conditions. So this condition can only be possible provided that the speed of a generator under all the load conditions, so that can be maintained constant, right? So the speed of the generator will be constant, so when the speed of the turbine, or which is say coupled to the generator, that is maintained a constant. Okay, so I repeat this one. The speed of the generator will be constant provided the speed of the turbine, so that is kept constant. And as we know that the load which is there coming onto the Pelton wheel, so that is a variable load, it is a fluctuating one. So when the load on the turbine, or that is a generator, that decreases, so it is bit obvious that the speed of the generator that increases beyond the normal speed, isn't it? So with the reduction in the load on the generator, the speed of the generator that increases tremendously. Okay, so when the speed of the turbine also increases beyond the normal speed, and if the turbine or the generator is to run at constant speed, it is necessary that the rate of flow of the water to the turbine should also be decreased. It should be reduced till the speed of the turbine that reaches to a normal level. So this process, this mechanism by which the speed of the turbine that we keep as a constant under variable load condition, so this phenomena, this process that we call as a governing of the turbine. So I hope that you have understood the meaning of the governing of the turbines, and the arrangement which is shown for the governing of the Pelton wheel. This mechanism that consists of the different elements. So I can see here the oil sump, okay, so that is filled with the required oil. Then I am having a gear pump, or this pump is also known as, let us say, the oil pump. Okay, so this oil pump that will be driven by the input or the power that can be obtained from the turbine shaft. Then we are having the relay cylinder or a servo motor here. Okay, the control valve or the distribution valve or the relay valves. Okay, relay valve or the control valves, we are having valve V1, valve V2. Then toward the upper left corner we can see that there is one centrifugal governor. Okay, we can call also this as a pendulum, and this is normally driven by a belt or a gearing arrangement from the turbine shaft, isn't it? So I can see that this is connected, the centrifugal governor is connected to the main shaft of the turbine. I am having a number of pipings, or the number of pipes which connect the oil sump with the control valve, and the control valve with the servo motor, right? And I do have a spear or a needle which is provided, say, in this particular toward the nozzle. Okay, spear and that rod, so that is getting displaced inside the nozzle. Now the arrangement that is shown here in this slide, so that indicate the position of the piston in the relay cylinder, the position of the control or the relay valve, and the fly balls of the centrifugal governor when the turbine is normally operated at the normal circumstances, or we can say it is operating at the normal speed. Okay, so whatever the positions that just now I had told, so those are considered the position when the turbine is running at its normal speed. Now assuming a phenomena that when the load on the generator decreases, right? For example, we will consider that the load on the generator that is decreasing. So it is bit obvious that the speed of the generator that will increase. Okay, speed of the generator is likely to increase with the decrease in the load on the generator. So this increases the speed of the turbine beyond the normal speed. Okay, the speed of the turbine that increases excessively. So due to this higher speed than the normal, the centrifugal governor, which is directly or mechanically connected to the turbine shaft, so that will also rotate at higher speed. And due to this higher speed of this centrifugal governor, the flyballs which are attached to the this governor, so they also try to move there in the upward direction, isn't it? They are moving in the upward direction due to the action of the increased centrifugal force. Okay, so that acts away from the center. So hence, due to the upward movement of these flyballs, the sleeve that will also move in the upward direction. Okay, these flyballs are say moving away from the center. Okay, they are moving upwards. Hence, the sleeve that also moves in the upward direction. Then this causes this horizontal lever. Okay, this causes this lever which is supported by a fulcrum here. Okay, lever that is supported by the fulcrum here. So that connects the sleeve and the piston rod of the control valve. Okay, so this is nothing but the piston rod for this control valve. Okay, piston rod and the control valve. So this also moves there as the sleeve that moves up, isn't it? As the sleeve that is say getting lifted, that is moving up, the lever will turn about the fulcrum. Okay, the lever is likely to turn around the fulcrum, about the fulcrum, and the piston rod of the control valve that moves in the downward direction. Okay, so it means that this piston rod that is getting pushed in the downward direction, the arrow which is as shown here, so that is moving in the downward direction. So this downward motion of this rod, this control valve, so that closes the valve V1. Okay, it closes the valve V1 here as such and opens the valve V2. Valve V2 is open, valve V1 is closed. Then the oil which is pumped from the oil pump admitted to the control valve or the relay valve. Okay, so it will flow under the pressure through the valve V2. Okay, it will flow under the pressure from the valve V2 to the servo motor and will exert a force on the face. Okay, that is the left face, that is nothing but on the face A of the piston of the relay cylinder. Okay, so force will be exerted on the back side, rear side of this piston, that is nothing but on the side A. So this piston along with the rod and the spear, so that will be say moving in the forward direction, that it will move toward the right. So as this piston that moves in the right direction, so this will decrease the area which is available for the flow of water at the outlet of the nozzle. Okay, so it means that this particular piston rod and the spear that is moving in the right direction, and that will help us to reduce the effective area which is available for the nozzle. Okay, so this decrease in the area of the flow, so that will in turn reduce the rate of flow of the water from the turbine or say to the turbine, and which will definitely help us to reduce the speed of the turbine. Okay, and when the speed of the turbine that becomes normal, it reaches to some normal level, then the fly balls, sleeve, lever and piston rod of the control valve, so they attain again their normal position, the normal condition as such shown in this arrangement. Okay, so this is nothing but a phenomena or the sequence of the what you can say the stages that will happen when the load on the generator decreases. But suppose opposite thing happens. Okay, the load on the generator that is increased. Okay, now the situation is the reverse one, opposite one. Now we assume that we will consider that the load on the generator that is increased. So due to which the speed of the generator and hence the speed of the turbine that will definitely reduce, that will decrease. The speed of the centrifugal governor, so that will also decrease, and hence the centrifugal force which is acting on the fly ball, so that is also getting reduced, it will also lower. So this motion, this phenomena that brings the fly balls in the downward direction, that is closer to the axis, and as these fly balls are say moving in the downward direction, the sleeve that will also move in the downward direction, which causes the lever to turn about the fulcrum and moving the piston rod of the control valve in the upward direction. Okay, so the piston rod of the control valve that will move in the upward direction. So this upward movement will result in the closure of the valve V2 and opening of the valve V1. Alright, as this moves in the upward direction, the valve V2 is closed now and the valve V1 is open. Now the flow of the oil under the pressure, so that will take place from the control valve, that will move through the valve V1 and to the servo motor, and this oil will get admitted on the B side of the piston, isn't it? So the force will be exerted on the face B for the piston. Initially it was there for A. Okay, now in this case the force will be exerted in the opposite direction, that is nothing but on the face B of the piston, which is shown in the arrangement. So this phenomena will make the piston to move along with the piston rod and the spear toward the left, isn't it? So this piston rod, then the rod, the spear, so that will be say moving toward the left, and this movement toward the left, so that will help us to increase the area which is available for the flow of the water at the outlet of the nozzle. So more opening that will be available at the outlet of the nozzle. So as the more opening is available, it means that the more area is available for the flow of the water. So due to this one, there will be increase in the discharge, there will be increase in the rate of flow of the water to the turbine, and obviously it is expected that the speed of the turbine is also likely to increase, isn't it? And this phenomenon will be continued till the speed of the turbine is becoming the normal. Okay, so that way it is the significance of the governing of the Pelton wheel. Okay, so we have understood here what the mechanism, for what purpose we are normally using the governing for the Pelton wheel, and we also discussed the two different cases. Okay, when the load on the generator decreases, how the mechanism will operate, and when the load on the generator increases, how the mechanism will operate. So this happens to be one of the important phenomenon in the operation of the Pelton wheel. Okay, so we'll stop here for this particular session, and the other things which are associated with the reaction turbine, okay, radial flow reaction turbine, that we'll discuss in the next session. Thank you very much.